The angle at the point of intersection of the two normals is called the angle between the two planes. We know the equation of the plane in the normal form is vector r dot n is equal to d. Perpendicular distance is given by d minus a dot n cap in the vector form. Hello dear students, welcome to this session of mathematics class. I am Mr. Niranjan, Faculty of Mathematics, Vidhyaashram PU College, the Temple of Excellence. Today in this session I am going to discuss regarding very important concept, that is angle between the two planes. So let us discuss regarding the angle between the two planes. In the previous class we have studied regarding the angle of intersection between the two lines. Now here the angle of intersection between the two planes. Now let us consider two planes. The angle between the two planes. The angle between the two planes is defined as angle between their normals. The angle of intersection between the two normals for the plane 1 and plane 2 will give the angle of intersection between the two planes. Now let us consider such two planes, plane 1 and plane 2. If n1 and n2 are the normal for the first and second plane, then here n1 is the normal, this is the normal for this plane, and n2 is the normal for the second plane, then theta is the angle of intersection between these two planes. Suppose if the angle between the two planes, then 180 minus theta, this is the angle between the planes, that is 180 minus theta. If this is theta, then this part is 180 minus theta. Then we shall take the acute angle as the angle between the two planes. So an acute angle between these two will give the angle between the angle of intersection. So here let us consider this theta. We shall take the acute angle as the angle between the two planes. Now here this is the angle between the normals, this is theta, that's equal to 90, this is 90 minus of 90 minus theta, again 90 minus of 90 minus theta, 90 minus of 90 minus theta, this is equal to theta. Hence this is the angle of intersection between the two planes. Okay, now let us find out the equation for this angle of intersection between the two planes in both vector as in Cartesian form. Now suppose if n1 and n2, if n1 and n2, vector n1 and n2 are the normals to the two planes, if n1 and n2 are the normals to the two planes, then theta is the angle of intersection between, theta is the angle between the two planes. See here, let us consider n1 and n2. Suppose if n1 and n2 are the normals, theta is the angle of intersection between these two normals, then this n1 is given by the vector equation. Since we know the equation of the plane in the normal form is vector r dot n is equal to d. Now let us consider the vector equation of the two planes. Let r dot n1 is equal to d1 and r dot n2 is equal to d2 is the vector equations for the plane 1 and 2. If n1 and n2 are the normals to the two planes, plane 1 and plane 2, these are the normals. If n1 and n2 are the normals to the two planes, and if theta is the angle of intersection between these two planes, then we know the equation of the plane in the normal form is r dot n cap is equal to d. Now let us write down the equation of the plane in the normal form for both the planes. So the equation of the plane 1 is r dot n1 is equal to d1, and for the second plane the equation is r dot vector n2 is equal to d2. Now so here theta is the angle between the two planes, so therefore the angle of intersection between the planes is given by cos theta is equal to vector n1 dot n2 divided by length of n1 into length of vector n2. So this will give us the angle of intersection between the two planes. So the angle of intersection between the two planes is modulus of n1 dot n2 vector divided by length of n1 into length of n2 will give the angle between the two planes in the vector form. Now to find the angle of intersection between the two planes in the Cartesian form, let us consider the direction ratios for the first and the second plane. Now write down the Cartesian equations. The Cartesian equation of the plane is so a1x, let us consider a1x plus b1y plus c1z plus d1 is equal to 0 for the first plane, and the second plane is a2x plus b2y plus c2z plus d2 is equal to 0. Let us consider the Cartesian equations for these two planes. A1x plus b1y plus c1z is equal to plus d1, and another equation a2x plus b2y plus c2z plus d2 is equal to 0. So if a1, b1, c1 and a2, b2, c2 represent the direction ratios for the normals n1 and n2, then the angle of intersection between these two is given by cos theta is equal to modulus of, multiply this, a1, a2 plus b1, b2 plus c1, c2 divided by root of a1 square plus b1 square plus c1 square into root of a2 square plus b2 square plus c2 square. This will give the angle of intersection between the two planes in the Cartesian form. Okay. Whenever the equations of the plane in the Cartesian form, use this formula cos theta is equal to, just use the direction ratios. Whenever the equations of the plane in the vector form, then cos theta is equal to n1 dot n2 divided by length of n1 into length of n2 under mod. So this will give the expression for angle of intersection between the two planes. Okay, that's it. Now listen to me, I will explain once again. So the angle of intersection between the two planes is nothing but the angle at the point of intersections of the normals n1 and n2. The angle at the point of intersections of the two normals n1 and n2. Let us consider two planes, and theta is the angle between the two normals n1 and n2. Then if n1 and n2 are the normals, theta is the angle between the two planes. Then the vector equation in the normal form is r dot n is equal to d. Now therefore r dot n1 is equal to d1 and r dot n2 is equal to d2 are the vector equations for the plane 1 and 2. If theta is the angle between the two planes, then cos theta is equal to n1 vector dot n2 vector divided by length of n1 into length of n2 vector will give the angle in vector form. Now to find the angle of intersection between the two planes in the Cartesian form, let us consider the Cartesian equations of the plane a1x plus b1y plus c1z plus d1 is equal to 0 and a2x plus b2y plus c2z plus d2 is equal to 0. Then if a1, b1, c1 and a2, b2, c2 represent the direction ratios for the normals n1 and n2, then the angle of intersection between them is given by cos theta is equal to a1, a2 plus b1, b2 plus c1, c2 divided by square root of a1 square plus b1 square plus c1 square into square root of a2 square plus b2 square plus c2 square. So thus, using these two formulas, we are going to find the angle of intersection between the two planes. Okay, hope you followed this very important concept. Now suppose if the two planes are perpendicular, if P1 is perpendicular to P2, if the two planes are perpendicular, then this A1, A2 plus B1, B2 plus C1, C2 is always equal to 0. If the two planes are perpendicular, then this value A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Suppose if the two planes are parallel, if they are parallel, then we have A1 by A2, the ratios are proportional. B1 by B2 is equal to C1 by C2. So this is the condition for a parallel. So for if the two planes are parallel, then A1 by A2 is equal to B1 by B2 is equal to C1 by C2. If they are perpendicular, A1, A2 plus B1, B2 plus C1, C2 is equal to 0. Okay. These are very two important concepts. Let us take a problem based on this. Now, find the angle between the two planes. First plane is 2x plus y minus 2z is equal to 5 and 3x minus 6y minus 2z is equal to 7 using vector method. This is very important problem for 3 marks. You may expect this type of problems for 3 marks. Now, what is given? The given vector equations. Write down the equations. Given equations are, what is the given equation? 2x plus y minus 2z is equal to 5. Another equation is 3x minus 6y minus 2z is equal to 7. Okay. Now here the normals are n1. So now therefore vector n1 can be written as the coefficient of x, y and z. So n1 is 2i plus j minus 2k cap, and n2 vector n2 is equal to 3i cap minus 6j cap minus 2k cap. So this here from this equations we can write n1. n1 is equal to 2i plus j minus 2k and n2 is equal to 3i minus 2j minus 2k. Now if theta is the angle, between the two planes n1 and n2, if theta is the angle between the two planes n1 and n2, we have cos theta is equal to n1 dot n2 divided by length of vector n1 into length of vector n2 under mod. Now this is equal to, this can be written as the dot product of these two. Simplify this. So 2 into 3 mod 2 into 3 plus 1 into minus 6 plus minus 2 into minus 2. Minus 2 into minus 2 mod whole divided by the square root of n1. Length of n1 is root of this. 2 square is 4 plus 4 plus 1 square is 1. Again 2 square is, so 4 into root of 3 square is 9 plus 6 square is 36 plus 2 square is 4. So simplify this. This can be written as, this is equal to mod 2 3s are 6 minus 6 then minus 4 divided by root of 9 into root of 6 plus 36 plus 4 is 40 plus 9 is root 49. So this can be written as minus 4 divided by 3 into 7. This is equal to minus 4 by 21. So this is nothing but 4 by 21. So cos theta is equal to 4 by, therefore the angle of intersection is given by, since cos theta is equal to, remove mod 4 by 21, theta is equal to cos inverse of 4 by 21. So the angle of intersection between this is given by theta is equal to cos inverse of 4 by 21. This is the required angle. So the angle of intersection between these two planes is 4 by 21. That's it. Okay. Very simple problem. So same type of problems we did in vectors and also in the equations of the lines. Now let us come to the next problem. Same. Find the angle between the two planes. 3x minus 6y plus 2z is equal to 7 and 2x plus 2y minus 2z is equal to 5. Same here. What is given? The lines are given. Vector n1 is equal to 3i minus 6j plus 2k and vector n2 is equal to 2i plus 2j minus 2k. The angle between them is given by cos theta is equal to mod of n1 dot n2 vector divided by length of n1 into length of n2 under mod. Simplify this. So cos theta is equal to modulus of n1 dot n2. So this is 3 into 2 plus minus 6 into minus 6 into 2 plus 2 into minus 2 divided by root of 3 square is 9 plus 6 square is 36 plus 2 square is 4 into root of 2 square is 4 plus 2 square is 4 again minus 2 square is 4. So this is equal to 3 2s are 6 minus 12 minus 4 divided by root of 36 plus 6 is 40 plus 9 is 49 into root of 4 3s are 12 this is. So this is equal to 6 minus 12 is minus 6 minus 4 is minus 10 divided by 7 into this can also be written as 4 3s are 12, 4 is nothing but 2 root 3. So 2 root 3. This is equal to, you can divide 10 by 7 into 2 root 3 or you can divide 5 times. This is 5 by 7 root 3. So 5 by 7 root 3 is the angle of intersection. Cos theta is equal to 5 divided by 7 root 3 or theta is equal to cos inverse of 5 divided by 7 root 3. Or if you want, you can further simplify by rationalizing the denominator. You can simplify. So the angle of intersection between the lines between the two planes is given by theta is equal to cos inverse of 5 divided by 7 into root 3 is the angle between the two planes. Hope you followed. So these are the few problems based on angle of intersection between the two planes. That's it. Okay. Let us come to the next concept. I'll explain the next concept. Distance of a point from a plane. To find the distance or the perpendicular distance of a point from a plane. Now consider a point P. Let us consider a point P with position vector A and a plane pi 1. Let us consider a point P with position vector OP is equal to vector A and a plane pi 1 whose equation is the vector equation of the plane is r dot n cap is equal to d. Now the vector equation is r dot n cap is equal to d. Now let us consider another plane pi 2. Pi 2 is another plane which is parallel to the plane pi 1. Let us consider another plane pi 2 which is parallel to the plane pi 1 and the unit normal vector is n cap for the plane 2. Hence its vector equation is given by, the vector equation is r dot n cap is also equal to, this is d1 and d2. Now hence the equation is given by r minus a dot n is equal to 0. Now this can be written as vector r dot n minus vector a dot n cap is equal to 0. Therefore vector r dot n cap is equal to vector a dot n cap. So that is vector r dot n cap is equal to vector a dot n cap. Thus the distance ON dash of the plane from the origin is a dot n cap. The distance O to n dash. So the distance from O to n dash, this is given by vector a dot n cap. So therefore the distance, that is P to Q distance, the distance PQ is given by, the distance PQ from the plane pi 1 is given by, so that is here this is the distance, that is ON minus ON dash, this total distance minus this distance. So that is nothing but ON minus ON dash, that's equal to D minus A dot n cap, vector A dot n cap. So hence the equation is vector r minus A dot n cap is equal to 0, that is r minus A dot n cap is equal to 0 or r dot n cap minus vector A dot n cap is equal to 0, which implies r dot n cap is equal to a dot n cap. So that is r dot n cap is equal to a dot n cap. So here the distance ON dash from the origin is given by, so the distance O to n dash from the origin is given by, this is the distance, that is a dot n cap, vector a dot n cap. So therefore the distance P to Q from the plane pi 1, that is, see the diagram, the distance from P to Q from the plane pi 1 is given by ON minus ON dash, that is this total distance ON minus ON dash will give us the distance PQ. So that is ON minus ON dash. What is ON? ON is D minus, what is ON dash? ON dash is equal to A dot N. So therefore, hence the distance is given by mod of D minus vector A dot N cap. So which is nothing but the length of perpendicular from a point to the given plane. Hence, length of perpendicular from a point to the given plane in the vector form is given by mod of D minus vector A dot N cap. This is the length of perpendicular distance. Perpendicular distance is given by D minus A dot N cap in the vector form. Now let us find out the length of perpendicular in the Cartesian form. Now for the Cartesian form, let us consider, let P x1, y1, z1 be any point on the line ax plus by plus cz minus d is equal to 0. Standard equation of the plane. So let x1, y1, z1 be any point on the plane ax plus by plus cz minus d is equal to 0. So let us consider, let P x1, y1, z1 be any point on the plane whose position vector is vector A on the plane ax plus by plus cz minus d is equal to 0. The length of perpendicular is given by mod of ax1 plus b into y1 plus cz1 minus d divided by root of a square plus b square plus c square. This is the length of perpendicular. So hence the distance of a point from the plane in vector form is d minus a dot n, and whereas in Cartesian form the length of perpendicular is given by modulus of ax1 plus by1 plus cz1 minus d divided by root of a square plus b square plus c square. These are the formulas which we are going to use to find the distance of a plane from any point. Now let us consider one simple example based on this. Now find the distance of a point 2, 5, minus 3 from the plane whose vector equation is given by r dot 6i minus 3j plus 2k is equal to 4. Very simple here. So what is given? The points 2, 5, minus 3, these are nothing but x1, y1 and z1. And what are the vector equation? Vector r dot 6i minus 3j plus 2k is equal to 4. This is nothing but r dot n is equal to d. Here n is nothing but vector 6i minus 3j plus 2k and d is equal to 4. Now what is therefore what is the formula to find the distance? Therefore the distance is given by modulus of ax1 plus by1 plus cz1 minus d divided by root of a square plus b square plus c square. Now this is nothing but, here what are the points? These are the points x1, y1, z1 are 2, 5, minus 3, and a1, a, b, c is nothing but 6, minus 3, and the distance from the point is given by modulus of ax1 plus by1 plus cz1 minus d by root of a square plus b square plus c square. Substitute the values. So these are the values of x, y and z. x1, y1, z1 is 2, 5, minus 3, and a is 6, b is minus 3, c is equal to 4. Substitute here. This is mod of a. A is 6 into x1 is 2 plus b. What is b? Minus 3. y1 is 5 minus 3 into 5 plus c. C is equal to 2 into z1 is minus 3. 2 into minus 3 and minus, what is the value of d? D is equal to 4 here. d is equal to 4 divided by root of a square plus b square plus c square. 6 square is 36, 3 square is 9 and 2 square is 4. So that is 36 plus minus 3 square is plus 9, 2 square is 4. This is equal to 6 2s are 12 minus 15 minus 6 minus 4 divided by square of 36 plus 4 is 40 plus 9 is 49. This is equal to modulus of 12 minus 15 is minus 3 minus 6 minus 4 is minus 13. Minus 13 divided by 7. This is equal to 13 divided by 7. So therefore the distance is given by 13 divided by 7 is the distance. The distance of a point 2 comma 5 comma minus 3 from the plane is d is equal to small d is equal to 13 by 7. That's it. Hope you followed. So that's all regarding this problem is concerned. So you may expect a problem based on this for 3 marks. Okay, right. So that's all regarding today's session. Let us meet with a different concept in the next class. Thank you very much.